Well, thanks everybody. I know I'm the only thing standing between you and the Irish pub, so I'm going to make this short and sweet. It's been a long day. What I'm going to present to you today is really conceptual in nature. We really approach this as it's a thought process of how we can really start going down the road of really measuring beneficial use attainment. You know, can we really measure these things? So it's really a big picture thing. And I do want to recognize Betty Fetcher in the audience had a big hand in this presentation, Eric Stein, and as well we worked with Greg Gearhart and Chris Began at the State Water Board. Some of their ideas have been incorporated into this as well. So we all know the big picture. We already heard this today. Lots of monitoring going on. We're using lots of different indicators, lots of methods, lots of tools out there. And probably at any point in time, we can say quite a bit about ecosystem health. We have a lot of information out there. But really, when we're looking at all the various indicators that we're measuring, how do those relate to something we call beneficial uses? Are we making those connections? Can we actually measure that? Are we actually attaining those? And that's really what the basis of my talk is today, is to really start us down that road thinking how we can actually do this. Now, beneficial uses are a big deal for California's water quality program. They are a major part of establishing water quality standards, which essentially establish water quality goals. They're the first part of this. And they also are a big part of establishing the objectives. These are the numeric or narrative criteria, these objectives that are established to protect those beneficial uses. So they really are the cornerstone. They're the key, the holy grail that we want to assess. There's numerous beneficial uses. You can read them all here, and I've just categorized them through large categories of human uses, habitat types, locations. These are all really focused on habitat. And then something I call process and function. Things like migration, spawning. A lot of these are related to fish, freshwater fish, as you can see. Obviously, these are the things that people in the room would really be interested in. But just so you know, there's lots of beneficial uses. There's more. Other regional boards have added additional uses, but these are the big 23. So, okay, well, we have these beneficial uses, but what are we missing at this point? There's many programs out there, regional boards, oversee programs, SWRCB 303D. We have all these needs. We have these information needs for various programs. Well, one of the major things that are missing is a way for integrating information from these traditional water quality indicators, all the things we're familiar with, and really having that way to translate all that information to that evaluation of beneficial use attainment. Really the central theme of why we're here for this special session. We also need a way to identify additional indicators so that new indicator development is targeted and complementary to existing tools. We definitely don't want to duplicate efforts. We don't want to have redundant indicators. We don't want to develop an indicator that's really not going to be useful for assessing that beneficial use. So we want to be really targeted in how we approach this. So if we have these things in place, we can really begin to answer some fundamental questions and really get at that issue of, are we attaining all those various beneficial uses you saw earlier? Obviously, with that information, better decision making, really establishing those really tight linkages to those programmatic goals, really what we ultimately want to do. So there's some significant challenges to going down this road. I mentioned those numeric and narrative objectives. Most beneficial uses are narrative in nature. They really don't have those, don't easily lend themselves to direct quantitative evaluation. You kind of have to guess what they mean and how our indicators relate to those. Definitions aren't uniform across all the regional boards. Some are, some aren't. Some have a different definition altogether for the same beneficial use. So you have to kind of juggle that as well. You're going to see in some of the definitions that a lot of these uses are very complex and they're integrated in nature. They're integrating different parts of the habitat, of different taxa. So how do we deal with that? Like I said, multiple taxas, trophic levels, all these things that are very complex ecosystem processes. So again, really, how do we translate all that data we're collecting to really reach these integrated endpoints? So what are we hoping to achieve with this nascent effort here. It's really, again, the key is integration of information from multiple lines of evidence. You've heard that all today through the various talks before me. I'm not going to really talk about how we integrate. You heard a lot about that today, but that is a key part of this process. We next need that translation of assessment results for interpretation, a very key part of this. And once we have that in place, really building this into some kind of what we're calling a decision support system for folks to determine which organisms, which response indicators are most appropriate for assessing that beneficial use. And under different scenarios, there are going to be different instances where one beneficial use might not apply. And so we need to kind of determine that. So really the key here is starting this process is as a conceptual framework. We need something to guide, to standardize how we go about approaching this. And that's really the gist of the rest of my talk. So the rest of the slides I'm going to show you are going to focus on two beneficial uses. We took the wild, which is wildlife habitat, and the cold habitat beneficial use. You might wonder why we chose a wildlife habitat. We're starting on the path of looking at trying to relate our water quality goals to higher trophic levels. So we thought this was kind of in line with what we were trying to do. So we started with wild, but we also wanted to kind of build it out for other ones. So I'm just going to show you two examples, and these are just things we came up with and points for discussion. And we'll have a special workshop after to kind of really delve into the details of this. So I'm going to show you these in sections and just kind of try to walk you through them. Really don't focus on the details. You're not going to be able to read what's all on here, but just kind of the overall theme and the approach. And focus on, is this approach working? Is this something that could be useful as we try to make these linkages? Okay, so pay attention to the legend. And the legend is going to be built out moving to the right. And we started, this is one approach. We're not saying this is the right approach, the one approach we could use, but it is a approach. So we call the attribute, these are just basically large attributes associated with the Clean Water, CWA, Clean Water Act. And this is usually how we parse it out by chemical, physical, biological. And this is the wild definition. We thought, well, let's just look at the definition, remember the narrative definition, and just really deconstruct that. And what is it trying to say? And so that's what we did here. And this is the definition deconstructed, associating each one of the parts of the narrative to, is it the physical habitat, is it biological, is it the chemical? So that's where we started. You can do this for all the beneficial uses, right? And then we looked at indicator class. So what is the indicator class appropriate for that part of the definition? You can just see for water directly ingested or absorbed, we have aquatic toxicity. And then we thought it was important to have a rationale of why you want to measure that. It keeps you kind of focused on, what this is actually trying to achieve with that indicator class. So we did that for all of the indicator classes, and we have a rationale. And again, you probably can't read most of that, but and then we're looking at how you could directly measure that indicator class. So this would be an intensive way of data that you would gather. As you can see, it's really looking at function. It's a direct measure. This would be a more expensive way to do that, but if you really want to look at, is that function happening in that habitat, this is how you would do it. And you can see things like nest surveys, burrow occupancy, gut content analysis, pretty intensive stuff, pretty specific stuff. But this would be the way to get at it. But if you didn't have the resources to do that, potentially you want to do this indirectly. This is maybe a lot of the things, if that's wordy, that we're more familiar with. Things like, these are surrogates basically. A little less expensive, maybe more rapid ways. You've heard about CRAM today. The PHAB would be a way to do this. In some cases, it might be a causal assessment looking at stressors. So this is an indirect way to look more at what we consider conditions. So it's assuming that that function's happening, but you're really kind of getting more at the condition of the habitat. So this is the wild beneficial use. Again, just one example of kind of the thought process here. Just again, making sure that the indicators we're measuring, the rationales there, it's really focusing in on the ultimate goal is that, that measurement of that beneficial use. So that was the wild example. And you can see how this could be useful for development of a decision support system. Taking these various types of data and how you would use them to kind of get at these various facets of that beneficial use. And I did want to mention too, Brock had mentioned the idea of trade-offs. Sometimes you're going to have to make decisions. This is that decision support where you might, this is going to be too expensive, too costly, too much time investment. We're going to have to do it the more rapid way. So you can see how that's all built into this. Okay, wild beneficial use, I'm going to show you the cold. A little different approach. This is more of a matrix approach, a lot more detail. Again, I don't want you to focus on everything you're going to be seeing on the slide, but really kind of the rationale of how we develop this. So again, you say same attributes for the Clean Water Act. I'm just showing you chemical. I'm going to show you this in parts too. It's very hard to put it all on one slide. But in this case, we actually took relevant water quality objectives. These are objectives that are found in the various basin plans that we found. So these are actual objectives. Some of these are narratives. Some of these have numeric criteria associated with them. Temperature, pH, dissolved O2 usually have some kind of threshold associated with it. Biostimulation, oil and grease are narrative objectives. But we thought, we'll take the objectives, look at them, which ones, how are they relating to the attribute. That's our first step, so you can see that. And then we talked about endpoints. So what endpoint is kind of where the definition gets integrated in. So the beneficial use definition is kind of part of that. And you can see how we're looking at effects of the organism, for this case of water not directly ingested or water directly ingested. Something directly ingested is really getting at toxicity, and that's really what we're measuring in this case. Whereas water that's not ingested would really be more looking at the chemistry. Is the water cold? Does it have enough dissolved oxygen, etc.? And so I'm building this out further. What we call receptors, which are really just taxa. It's a certain biological community. I'm not saying that's the right definition to use. This is just a definition to use. And Fraser did mention he had some definitions for some of these things, and I think that's a big important part of this is really getting agreement on what these definitions means, because what an endpoint is for some people may be different for others. So we need to really be standardized in what we're calling this. But for this exercise, we said receptors. These are the common things we measure: diatoms, algae, BMIs, benthic macroinvertebrates. You've heard about all these today. So you have different receptors, and then different response indicators. In this case, things like community conditions, species richness, composition, really applies across the board. And I stopped with fish as a higher trophic level, but you could have this for amphibians, for things like birds, eventually, as other indicators are developed. I'll talk a little later about the habitat surrogate. That's more for the physical habitat. Okay, so it's finally built out to its fullest extent. So all these metrics that you're seeing here are the things we actually measure in the field. Again, don't focus on what these are, but we're just trying to list them all out. So all of these things would feed into that response indicator, to that measurable component, to that endpoint, to these water quality objectives. And then I just put in methods, things that we would use to measure some of these metrics. Again, it's a thought process, conceptual approach for how we would actually make the linkages from here to our metrics in our indicators. Okay, so again, sticking with the cold, we're just moving into the physical. Same idea, everything I was just showing you before, we're just doing it now for the physical. In this case, we broke it up into hydrology and habitat. Before, I just had the habitat for wildlife. Again, that was focused on terrestrial. I think I failed to mention that, but this is aquatic, so we're going to have some more aquatic element to the physical habitat. Again, relevant water quality objectives. In some cases, there weren't any, especially for physical habitat. We found very heavy on the chemical. You didn't really have a narrative objective for some of these things like flow criteria and these things. In some cases, we did have exotic vegetation, for instance, for habitat. There was one of the basin plans, I think that's region 2, that actually has a narrative objective for exotic vegetation, but it's only a single regional word. Again, the measurable component, you can see flow velocity would be one of them, water availability, the quantity, epifaunal substrate. So again, that component feeding into the endpoint and then feeding into that relative water quality objective. Building it out further, we got the receptors again sticking with our same ones, algae, fish, bugs. And then response indicator, again, we're looking at things like community composition, et cetera, as you can see. And then in this case, with habitat, maybe there's a surrogate thing where we're assuming that certain flows, you're gonna have this certain type of community present with those flows. So maybe you can just get away by measuring the different types of flow habitats. And then finally, again, just building out what those specific metrics are, and then some of those examples of how you would measure those in the field. Okay, and again, just some redundancy here, building it out for biotic, the same thing. Again, these are actual water quality objectives from the basin plans, as you can see, pretty light on objectives for biology, as it currently is in the basin plans. But we have those endpoints again, really the measurable component. Again, this is where the trophic gets quite complicated when you start looking at the biology. You can see, where things like density measures, evidence, reproduction, recruitment, things that are tough to measure, right? Fairly costly if you want to really know these processes that are occurring. But we do have some metrics that we typically collect when we're out there. Things like for fish, catch per unit effort would be an example of that. And then we have current ways through bioassessment, maybe electrofishing would be something to use for fish. Again, these are just concepts, just organizing constructs that as we work through this, we wanted to kind of play with. Are we on time here?
Good, yeah.
Okay. So that really, that's the bulk of it. We're going to have a special workshop afterwards to really kind of look at these in more detail, people to react to them and have hopefully we'll get some suggestions on moving forward. This is our really our first step on that. So for us, what we're interested in doing is, as I mentioned, this is a thought process. We'd like to build this out further. We think the best way to do that is really to convene an ad hoc committee, get some people in the room who are interested in really getting at beneficial use attainment, how you would measure that, and really get a larger group to guide this development process. This was just basically Eric, Betty, and I, Chris Began in a room trying to think this out as a small group, but we really realized we need a much larger group to make this work in the long run. And then facilitate discussions with stakeholders, a big part of this, solicit input, obviously develop those matrices for all the other beneficial uses of interest, things like estuarine and migration, and really ultimately seek funding. We would like to seek funding to really build this out, and really do a thorough job on this. So this leads me, I think this is my last slide, the special workshop where we'll really get into the nuts and bolts of this. Won't be a structured presentation. This is really going to be a discussion. So if you're interested in the topic, definitely join us. But it's really going to be more getting people's reaction, getting people's thoughts on, to answer some of these questions. Are we on track? Is this the right approach? Was this an appropriate structure as you look at that in more detail? Did that effectively make that translation? Was that workable? Is that something that we need to build out further? And is it really ultimately making those connections with program needs? And then as well, I mentioned identify an ad hoc committee, technical members, people who really want to work on this, get their hands dirty, and help build this out over time. With that, thank you very much.
Okay, any questions for Chris? You have anyone up there? Okay.
Thanks, Chris. This is really useful, and it really helps set a framework that we can all have dialogue about, which is a huge step forward. So thanks for doing this. At the end, on the far right column, you get to the various, the blue, all the things we are collecting. Every other talk today, we talked about how difficult it is to integrate a set of different metrics or parameters together, often just within one class of data, chemistry, habitat, etc. How do we move forward to integrate this diversity of various metrics into a final objective?
No, it's a good question. I didn't touch on the integration. I think a lot of the talks we heard today, Fraser gave some great ideas of how you could go, some approaches to integration. I kind of stayed away from that today. I think there's lots of ways we can do it, but I think it's important to have that conceptual framework really nailed down first, and I think the integration will come. I think it's tractable. We have ways we can integrate data. There might be a better way than others, and that's the discussion we could have. But I think when this is laid out and we have everything on board, it'll help us think, this might work as an integrated way. But I think until we have that structural framework, we have a standardized vocabulary for how we're doing this, it'll be harder. So this is kind of a first step on that.
That's great, thank you.
Other questions or comments?
I had one comment and a question. The comment is I would suggest maybe including in your list of beneficial uses the proposed and likely to occur traditional and cultural use of fish by tribes.
Yeah, I didn't put them up there. When we have the discussion afterwards, a special workshop, we have a slide that lists all those other things.
Okay.
Yeah.
And then the question was, if to me this looks really exciting, but I like lots of data collection like most people in the room. It would seem that there's a couple things I was wondering if you could sort out. One is sometimes in processes like these, the people who can pay for somebody to be in the room really define what comes out at the other end. And that isn't necessarily the same people who benefit from the beneficial use.
Right.
Sometimes it is, like SWRCB does a good job of that, but it doesn't always happen that way. So, it'd be worth thinking about how to make sure this is a fairly democratic process and wondering how you do that. And number two, if you could see an opportunity for sort of backfilling those WQOs, those water quality objectives that aren't defined, using the stuff on the right to actually define them. So using ecology to define the objectives as opposed to what usually happens.
The other way around.
So,
Absolutely.
two good questions. Thanks.
Yeah, I think I didn't touch on it. I think the human value part has to be a component of that. And there's ways to bring economists, social scientists into this discussion. We approached this as biologists, as ecologists, and we knew this, us in the room as biologists were going to be missing on a huge facet of a lot of those beneficial uses you mentioned, cultural, et cetera. You have to have some kind of measure of human values. That would be obviously next step when we build out a technical work group is to have that voice be part of this. So, and does that answer?
And working backwards from the ecology to the water quality objectives. Does that make sense? So if the water quality objectives
Objectives undefined, actually using it as an opportunity to have biology drive policy.
Yeah, absolutely. I mean, that would be a great way to approach the missing pieces. Yeah, makes sense.
Other questions or comments? I think I would just say, Fraser, going to your first point, yes, for sure, any discussion like this would have to have a very inclusive discussion of affected stakeholders, and I think that was one of the points on Chris's slide, because obviously the last thing I think you want is lock a bunch of people in a room, a bunch of geeky scientists, and come up with something and just say, here's the answer. Right? I think that's the last thing you want is it really has to be something that's an inclusive discussion about with the ultimately affected people who are going to live with it.
And I think really at that conceptual part too, it's key to have those people there, because you want to have them at the beginning to help build this out. It's the only way to make it work.
Any other questions or comments for Chris before I turn it back over to Jim?